So let's try to address some of the shortcomings in user-based collaborative filtering with a technique called item-based collaborative filtering. And we'll see how that can be more powerful. It's actually one of the techniques that Amazon actually uses under the hood, and they've talked about this publicly, so I can tell you that much. But let's see why it's such a great idea. So we talked about user-based collaborative filtering, where we recommend items based on what people similar to you liked that you haven't seen yet or experienced yet. And we talked about some of the problems with user-based collaborative filtering. So what if we flip it all on its head, and instead of basing our recommendations on relationships between people, we base them on relationships between items? And that's what item-based collaborative filtering is. So this draws on a few insights. For one thing, we talked about people being fickle. Their tastes can change over time, so comparing one person to another person based on their past behavior becomes pretty complicated. You know, people have different phases where they have different interests, and you might not be comparing the people that are in the same phase to each other. But an item will always be whatever it is. A movie will always be a movie. It's never going to change. Star Wars will always be Star Wars. Well, until George Lucas tinkers with it a little bit. But for the most part, items do not change as much as people do. So we know that these relationships are more permanent, and there's more of a direct comparison you can make when computing similarity between items, because they do not change over time. The other advantage is that there are generally fewer things that you're trying to recommend than there are people you're recommending to. So again, 7 billion people in the world, you're probably not offering 7 billion things on your website to recommend to them. So you can save a lot of computational resources by evaluating relationships between items instead of users, because you probably have fewer items than you have users in your system. And that means you can run your recommendations more frequently, make them more current, more up-to-date, better. You can use more complicated algorithms because you have less relationships to compute, and that's a good thing. It's also harder to game the system. So we talked about how easy it is to game a user-based collaborative filtering approach by just creating some fake users that like a bunch of popular stuff and then the thing you're trying to promote. With item-based collaborative filtering, that becomes much more difficult. You have to game the system into thinking there are relationships between items, and since you probably don't have the capability to create fake items with fake ties to other items based on many, many other users, it's a lot harder to game an item-based collaborative filtering system, which is a good thing. While I'm on the topic of gaming the system, another important thing is to make sure that people are voting with their money. So a general technique for avoiding shilling attacks or people trying to game your recommender system, make sure that the behavior that you're basing it off of is based on people actually spending money. So you're always going to get better and more reliable results when you base recommendations on what people actually bought as opposed to what they viewed or what they clicked on. Okay. All right, so let's talk about how item-based collaborative filtering works. It's very similar to user-based collaborative filtering, but instead of users, we're looking at items. So let's go back to the example of movie recommendations. The first thing we would do is find every pair of movies, every movie pairing that is watched by the same person. So we go through and find every movie that was watched by identical people, and then we measure the similarity of all those people who viewed that movie to each other. So by this means we can compute similarities between two different movies based on the ratings of the people who watched both of those movies. So I have a movie pair, okay, maybe Star Wars and The Empire Strikes Back. I find a list of everyone who watched both of those movies. I compare their ratings to each other. And if they're similar, then I can say these two movies are similar because they were rated similarly by people who watched both of them, okay? That's the general idea here. That's one way to do it. There's more than one way to do it. And then I can just sort everything by the movie and then by the similarity strength of all the similar movies to it. And there's my results for people who liked also liked, or people who rated this highly also rated this highly, and so on and so forth. And like I said, that's just one way of doing it. So that's sort of step one of item-based collaborative filtering. First, I find relationships between movies based on the relationships of the people who watched every given pair of movies. It'll make more sense when we go through the example. So for example, let's say that our nice young lady here watched Star Wars and Empire Strikes Back and liked both of them. So rated them both 5 stars or something. Now along comes Mr. Edgy Mohawk Man, who also watched Star Wars and The Empire Strikes Back and also liked both of them. So at this point we can say there's a relationship, there's a similarity between Star Wars and The Empire Strikes Back based on these two users who liked both movies. So what we're going to do is look at each pair of movies. We have a pair of Star Wars and Empire Strikes Back, and then we look at all the users that watched both of them, which are these two guys. And if they both like them, then we can say that they're similar to each other. Or if they both dislike them, we can say they're similar to each other, right? So we're just looking at the similarity score of these two users' behavior related to these two movies in this movie pair. So along comes Mr. Mustachy Lumberjack Hipster Man, and he watches The Empire Strikes Back, and he lives in some strange world where he watched The Empire Strikes Back but had no idea that Star Wars, the first movie, existed. Well, that's fine. We computed a relationship between The Empire Strikes Back and Star Wars based on the behavior of these two people, so we know that these two movies are similar to each other. So given that Mr. Hipster Man liked The Empire Strikes Back, we can say with good confidence that he would also like Star Wars, and we can then recommend that back to him as his top movie recommendation. So you can see you end up with very similar results in the end, but we've kind of flipped the whole thing on its head. So instead of focusing the system on relationships between people, we're focusing them on relationships between items. And those relationships are still based on the aggregate behavior of all the people that watch them, but fundamentally we're looking at relationships between items and not relationships between people. Got it? All right, so let's do it. We actually have some Python code that will use pandas and all the various other tools at our disposal to create movie recommendations with a surprisingly little amount of code. So the first thing we're going to do is show you item-based collaborative filtering in practice. So we'll build up people who also watched, basically. People who rated things highly also rated this thing highly. So building up these movie-to-movie relationships. And we're going to base it on real data that we got from the MovieLens project. So if you go to movielens.org, there's actually an open movie recommender system there where people can rate movies and get recommendations for new movies. And they make all the underlying data publicly available for researchers like us. So we're going to actually use some real movie ratings data. It is a little bit dated. It's like 10 years old, so keep that in mind. But it is real behavior data that we're going to be working with finally here. And we will use that to compute similarities between movies. And that data in and of itself is useful. You can use that to say people who liked also liked, right? So let's say I'm looking at a web page for a movie. I can right there and then and there say, if you like this movie, given that you're looking at it, you're probably interested in it, you might also like these movies. And that's a form of a recommender system right there, even though we don't even know who you are. Now, it is real world data, so we're going to encounter some real world problems with it. Our initial set of results aren't going to look good. So we're going to spend a little bit of extra time trying to figure out why, which is a lot of what you spend your time doing as a data scientist, correct those problems, and go back and run it again until we get results that make sense. And finally, we'll actually do item-based collaborative filtering in its entirety, where we actually recommend movies to individuals based on their own behavior. So let's do this. Let's get started. So that's item-based collaborative filtering, a wonderful idea thought up of people much smarter than me. But it did have its origins at Amazon, which is kind of cool. As you can see, it addresses a lot of the shortcomings of user-based collaborative filtering, and it works out really well. So let's actually put it into practice and start writing some Python code to make it happen.